In this lesson on functions and their inverses, we are going to have a look at restrictions. In our previous lesson, we learned about one-to-one functions and many-to-one functions. We heard that in a one-to-one function, every y value has only one x value, where in a many-to-one function, every y value has more than one x value. Now we're going to have a look at the inverses of these functions. But first, I'm going to remind you that inverse means that x and y swap around. So for a one-to-one function, the inverse will now have for every x value only one y value. Whereas for a many-to-one function, the inverse will be for every x value, there's now more than one y value. We know that a function's definition is for every x value, there's only one y value. So that means that a one-to-one function's inverse will be a function again, but a many-to-one function's inverse will not be a function. Let's have a look at the restrictions that we can add to the domain of a function. Here we have the straightforward parabola y is equal to x squared. This is a many-to-one function, and that means that its inverse will not be a function. We can, however, make a plan to ensure that the inverse will also be a function. And for this, we need to add a restriction to ensure that this function is a one-to-one function. A parabola is symmetrical. So if we want to ensure that it's a one-to-one function, we are going to have to draw only one half of this graph. And for that, we are going to add a restriction to the domain of the graph. To add a restriction to only draw half of this graph, we will have to focus on the axis of symmetry of this graph. And the axis of symmetry of this parabola is at x is equal to 0. So we can now choose to either draw the negative half of this parabola or the positive half of this parabola. If I now have a look at these two halves of my parabola, they are both one-to-one functions, which means their inverses will also be functions. To apply these restrictions, I need to already at the beginning add this restriction to the domain of the function. So for the first one, I'm going to say that I'm going to draw y is equal to x squared, but I'm going to add the restriction to the domain that I'm only going to draw the x values smaller or equal to 0. For my second option, once again, I'm going to draw the function y is equal to x squared, but I'm going to restrict it to only drawing the x values bigger or equal to 0. Let's have a look at how we are now going to draw these inverses. Let's firstly have a look at the complete parabola again. If I'm now going to draw the inverse of this graph, I'm going to reflect it around the line y is equal to x, which is the orange dotted line. If I do that reflection, my graph that I'm going to draw will look like this. And this is not a function because for every x, I have two possible y values. And therefore, we are going to restrict our parabola. So I'm going to start off by only drawing the values where x is smaller or equal to 0. If I now draw the reflection or the inverse of this one, I will have the following graph. And this graph will be a function. Or I could decide to rather draw the graph where only all the x values are bigger or equal to 0. And if I go and reflect this one around the line y is equal to x, I will have a graph like this. And this new graph is also a function. So to sum up, to ensure that my inverse will also be a function, I have two options of restrictions for my original function. I can firstly decide to choose all the x values smaller or equal to 0, and then when I draw my inverse, it will look like this. And my equation for my inverse will then be only the negative root of x. Or I can choose to have the restriction where all the x values are bigger or equal to 0. Then my inverse function will look like this. and the equation will now be all the positive square roots of x. You can also note that in both inverses, the domain is x bigger or equal to 0 because I cannot have a square root of a negative value. But if I want to go and add the range for the first inverse will be all the y values smaller or equal to 0 because we are only drawing the negative y values, and because inverse means the x and the y swap around. For my second option, my range will now be all the y values bigger or equal to 0, because in my graph you can see that I've only drawn the y values that are positive. And once again, if I look at the inverse, which says x and y swap around, y will have to be bigger or equal to 0.